In this video I want to take a look at computer vision, and to that end I've made this basic little starter app. It's based on Kiwi, which is a framework for Python for making GUI apps, and right now it looks like this. We have two images displayed side by side. There are functionalities, or there is the start of functionalities for image modification. We don't have any image analysis yet, and I'll show you what I mean by this. Then we have on the left side the original image, on the right side the analyzed image. We can save the images if we want, and we can reset. So for example, I have these modification methods, so I can make a black circle, and right now there's no analysis method applied over here, so it's just a straight copy. And you can see I can do this, and I also have this Gaussian blur, which is quite slow, the implementation right now, but it works. You can see that it's blurred wherever I click, using like a Gaussian average over the neighbors of the pixel. And it's duplicated over here. I can reset it, it's reset. So the first thing, maybe I should remove this annoying purple color, which is something used for debugging. And I think it's up here. No. This is not the best structured app, but as I said, it's just for playing around. And now we have a more neutral gray color. It's not very inspiring, but it's also not very jarring. So what I want to do now is to implement some analysis methods using OpenCV from Python. So let's make a new file that we call analysis methods, and we are going to make a function that we call binary threshold. And let's open that up. Actually, let me do it this way. So what we'll need is OpenCV. It's called CV2 for some reason. And we'll make the binary threshold, which should take an image array and the threshold. And I think this is actually correct. This function threshold returns through two values. The first is a computed threshold if we use an automatic thresholding algorithm, and the second is the actual thresholded image. So the way it works is that this threshold value is something we control, and anything with a pixel value less than that is set to 0, and anything with a pixel value higher than that is set to this value over here, which is just completely bright. So now let's try to hook this up. Let me actually go back here. Okay, so let's hook it up, and I have these drop downs, so let's try to run it again. I have these drop downs defined, and I want to put now this new method over here. And like I said, it's not the most beautifully structured code, but let's then I think we need to make another drop down. And on that drop down, then we add another button, exactly as above. We're gonna call this one binary threshold, and it will just be minimal size and Y, I guess, and then we just hardcode the height anyway. And when you press it, we want to do something. So here we set the modification method. Let's make a similar. So on the other dropdown, when you click one of those buttons, it sets the mod method, the modification method. So let's make something here that will set the analysis method. And we'll take the name of the method and then the dropdown so that we can automatically close it. And let us then go down here and make this analysis method. Again, it'll take a method name, the dropdown that we came from, and we'll do a match statement. And right now we only support this one. So anything else we want to raise an exception just to make sure that we're not inadvertently adding an annoying bug. And I think this field is never used actually, so let's remove that. And yes, we should only have it here. So that's great. And then once we have set it up, which we will do later, then we will simply say select method name, and quite possibly I think we also need this. So dropdown 2, bind on select, dropdown 2. Let's see if that works. That is not good. So what went wrong here? The problem is that here on release on the dropdown button we have to say we open dropdown 2, and now it says binary threshold and it updates the active method. Okay, but it still doesn't do anything, so we should go in here and look at image 2, and then we will set the analysis method, and we actually don't take any input. Well, no, we take the image as an input, and then we should call binary threshold with some threshold value, which we can put to 100. It seems fine. And then down here in the actual implementation of the image, put a default, and then maybe we do it another way. Maybe we do it like this. We'll say that it has a method that we call apply analysis, and the analysis is this function. Then if we go down here, we can say apply analysis. And what we want to do is exactly this. So we will take the image array that is just the image data for this image. Then we'll apply the analysis function on it. It should return another image. So let's actually denote that here. This should be an array. This should be an integer, and this should return an array, like so. So we apply the analysis, and then we call display. Let's see if that works. It looks pretty good. So you can see the light areas, they are becoming quite light. And the dark areas are becoming dark. So I actually think there's a little bug, which is if we do this, it will just reset the image and we would have to click it again. So actually, let's set something like this. And then we'll also add it as a field up here. And then whenever we click, we also call the update function. The update function is set here in the connect to. So when we update, we copy the image from the other one, and then we should say if the active analysis is not none, then we just run it on the image. So let's try that. And that didn't work. What did I do wrong? I forgot to write that. So let's threshold it and let's add. So it's quite nice. Let's try to add a blur. And let's see how that affects the thresholding. So you can see like it almost didn't do anything. Let's add a blur here. Now something happened. Okay. So that's quite a simple method, which maybe you can kind of see that it could be used for finding regions of similar structure. It's obviously not quite that nice on its own, but maybe if we grayscale the image and that is not intentional. Interesting. Okay, I've implemented some resize algorithm now, and basically whenever we display the image, we clear what was previously there, and when we create the app, this one I don't need. When we create the app, we bind the resize method to the size event. Now there's a little bit of a problem with that, which is that when we clear the canvas, you can see it becomes darker. It's probably because gamma correction is being applied to the images when they're shown. So there's some extra element on the canvas that does this gamma correction or like lightens the image. I'm not gonna worry about that right now because like the functionality is fine. So that was a little bit of a roundabout. Now let's look at another method. Let's hook up another method that we called like thresholding, and it's called to 0. So let's call it to 0 threshold. And we need the same stuff, so let's copy that. And this should be to 0 threshold. And I realize now I have okay, there we go. And now when we set the analysis method, we simply add another case. And it should take an image, and we want the to 0 threshold on the image, and we'll use 100 again. Now this method is not defined yet, but we can easily define that. And now we see it should be able to auto-complete it. And with that, we should be able to run it and try the to 0. So it's a little bit less harsh. That doesn't work. Interesting. It didn't work for some reason. Let's try with a different threshold, see what happens. Okay, so clearly something is wrong when we go to apply. We shouldn't just do it on the array, we should actually reset the array first. So here when we connect to the other, I'm gonna save a reference to the other, and then when we apply the analysis, we should say self.image array is first a copy of the other one's image array. Copy. Because now I should be able to run that and then that, and should be able to go back and forth. Okay. And reset still doesn't do anything on this one, which is fine, I guess. Let's now, not here, let's, again, not here. Let's go back and change the threshold to 100. So it's softer. But if what would happen if we set it to 10? Changing these parameters is also something we should do from the UI later. Okay, so if it's very low, it almost does nothing. And we saw before that a very high value was making it quite black. So that's interesting. Let's do one more. So what we're gonna do is, let's call it whatever. Let's call it binary threshold inverted. And we are going to do all of this again. And that's cute. Actually, it's not even a bad idea. So let's add that. And then we can modify this one to say should it be inverted? So if inverted, we return that one, otherwise we return this one. And we need to add it to the dropdown. That should be it. So now it should make the light areas black, then the dark areas white. So it should be exactly inverted of this one, which we see that it indeed is. So that's it for this video. This is just getting started. There's a ton of other interesting image analysis methods in this library, OpenCV. For Python. And I've been coding too much in Rust. And in another video, we'll take a look at some more interesting methods. If you want to use this Playground app, you just follow the instructions in the description. It will show you which commit you should go to get the basic app, and you can always just, if you want to use the latest code, you just use the latest commit on the repository. So that's it. See you in the next one.